Welcome to another episode of AI Frontiers, where we delve into the cutting-edge world of artificial intelligence and machine learning. Today we're diving deep into the realm of computational linguistics, or CS.CL, as it's often abbreviated. This field is all about understanding and modeling human language through computational methods, and it's at the heart of many advancements in AI, from natural language processing to machine translation and beyond. Our focus is on synthesizing 5 papers published on the arXiv preprint server from 2025-05-23 to 2025-05-23. In this presentation, we will be exploring the cutting edge of computational linguistics. Key themes include emotional awareness in large language models, multilingual reasoning, and front-end engineering benchmarks. We will also discuss the methodologies used and highlight groundbreaking findings. Finally, we will look at future directions and challenges in the field. Computational linguistics is a fascinating intersection of computer science and linguistics. It involves developing algorithms and systems that can understand, interpret, and generate human language. This field is crucial because it enables machines to communicate with humans in a natural and intuitive way, bridging the gap between human language and machine code. Whether it's powering virtual assistants, improving search engines, or aiding in language translation, computational linguistics is at the forefront of making technology more accessible and user-friendly. One dominant research theme is the push to make large language models, or LLMs, more emotionally aware. Researchers like Niranjan Chebrolu and his team are working on ways to make LLMs express emotions more like humans do. This involves fine-tuning models to understand and generate responses with nuanced emotional undertones. For example, Chebrolu's work has shown that targeted activation engineering can significantly enhance the emotional characteristics of LLM-generated responses. This means that future AI could be much better at understanding and expressing human emotions, making interactions more engaging and empathetic. Another significant theme is the evaluation and improvement of multilingual reasoning in large reasoning models, or LRMs. Ji-Rui Tam and colleagues are investigating how these models process and reason about information in different languages, aiming to make them more effective in multilingual contexts. For instance, Pham's findings reveal that large reasoning models tend to default to high-resource languages, like English, even when processing information in other languages. This insight is a crucial step towards developing more equitable models that serve users across diverse linguistic backgrounds. Front-end engineering benchmarks are also a hot topic. Hao-Yu Sun and his team are developing new ways to test multimodal large language models, or MLLMs, across the entire front-end development pipeline. This includes everything from web page design to code generation. For example, Sun's full front benchmark has exposed substantial gaps between current MLLM capabilities and human expert performance in front-end engineering tasks. This highlights the need for further development in this area. Curriculum-guided reinforcement learning is emerging as a powerful tool for enhancing multi-hop retrieval augmented generation, or RAG. Yuliu Ji and his team are using this approach to make RAG models more efficient and effective at answering complex queries. For instance, Ji's EvoRAG framework has demonstrated impressive improvements in multi-hop question-answering tasks, boosting exact match scores by up to 4.6 points while reducing average retrieval depth by 15%. This makes RAG models more efficient and effective. Several key findings emerge from the latest research. Emotional awareness in LLMs has been enhanced by Chebrolu et al., who have shown that targeted activation engineering can significantly improve the emotional characteristics of LLM-generated responses. Multilingual reasoning in LRMs has been evaluated by Tam et al., revealing linguistic biases and the need for more equitable models. Front-end engineering benchmarks by Sun and al. Have exposed gaps in MLLM capabilities, highlighting areas for further development. Reinforcement learning, as demonstrated by Ji et al., has improved the efficiency of RAG models. Additionally, Kambatma et al. Have evaluated the impact of persona prompting on synthetic data diversity, finding that while it improves lexical diversity, fine-grained persona details do not necessarily increase diversity noticeably. Researchers are employing a range of common techniques to achieve these results. Targeted activation engineering, as used by Niranjan Chebrolu, involves identifying and manipulating specific components within LLMs to control their behavior. This method shows promise for making LLMs more emotionally aware but requires deep technical expertise. Jiru Tam's work uses extensive evaluations across various benchmarks to expose linguistic biases in large reasoning models. This approach is powerful for identifying areas for improvement, but can be time-consuming and resource-intensive. Hao Sun's full-front benchmark employs a novel two-stage process to transform real-world web pages into clean, standardized HTML. This provides a more realistic and challenging testbed for MLLMs but requires careful curation. UEG's EvoReg framework uses curriculum-guided reinforcement learning to evolve a query rewriting agent. This method shows impressive for results, but relies on complex reward scheduling and optimization. Gorikambatla's approach involves sampling responses from LLMs with different persona descriptions and measuring their diversity with lexical metrics. This provides valuable insights into synthetic data generation and may not capture all aspects of diversity. Let's dive deeper into a seminal paper by Niranjan Shebrulu et al., titled Conversations, Love Them, Hate Them, Steer Them, 2025. The objective of this paper is to instill large language models with more human-like emotional expression. The authors use targeted activation engineering to identify and manipulate key components within the Llama 3.1 to 8b model. They derive emotional expression vectors from contrastive text pairs and apply these vectors to new conversational prompts. The results are impressive, with steered responses showing increased positive sentiment and greater personal engagement. This work offers a precise and interpretable method for controlling specific emotional attributes in LLMs, contributing to the development of more aligned and empathetic conversational AI. The significance of this work lies in its potential to make AI interactions more emotionally resonant and engaging. Next, we have Language Matters. How do multilingual input and reasoning paths affect large reasoning models? By Jiru Tam et al., 2025. This paper investigates how large reasoning models process and reason about information in different languages. The authors find that, despite multilingual training, these models tend to default to reasoning in high-resource languages like English. This can lead to performance declines when the models are constrained to reason in the same language as the input, especially for low-resource languages. The authors conduct extensive evaluations across various benchmarks, showing that the effective language choice varies by task type. This work highlights a critical step towards developing more equitable models that serve users across diverse linguistic backgrounds. Its significance lies in exposing linguistic biases in large reasoning models and paving the way for more inclusive AI technologies. Finally, let's explore full front benchmarking MLLMs across the full front-end engineering workflow by Hao Sun et al., 2025. This paper presents a new benchmark for evaluating multimodal large language models across the entire front-end engineering pipeline. The full front benchmark assesses three fundamental tasks: web page design, web page perception, QA, and web page code generation. The authors use a novel two-stage process to create a more realistic and challenging testbed for MLLMs. Their results reveal significant limitations in current MLLM capabilities, particularly in page perception, code generation, and interaction implementation. This work quantitatively demonstrates performance disparities across models and tasks, highlighting a substantial gap between current MLLM capabilities and human expert performance. The significance of this work lies in providing a comprehensive benchmark for front-end engineering tasks, driving further development in this area. Looking ahead, the future of computational linguistics holds promise and challenges. Researchers will continue to push the boundaries of what's possible, developing more dynamic and context-aware evaluation paradigms, improving the efficiency of reasoning tasks, and integrating multimodal data for holistic understanding. As we move forward, the field will likely see a greater emphasis on ethical considerations, cultural sensitivity, and the development of more human-aligned AI systems. In conclusion, the field of computational linguistics is making significant strides, but there are still many challenges to overcome. Researchers are pushing the boundaries of what's possible with large language models, from emotional expression to multilingual reasoning and front-end engineering benchmarks. As we look to the future, we could expect to see more sophisticated and emotionally aware AI, more equitable and inclusive language models, and more comprehensive benchmarks for evaluating AI capabilities. The journey is far from over, but the progress is inspiring. Synthesis created using AI tools. GPT, Mistral Large Latest, DeepRAM TTS, Grok Image Generation, Human Expert Review conducted. Potential oversights may exist. All references provided. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by Archive Preprint Server.